Okay, so picture this. It's the late 19th century. Two different scientists in two different labs are about to stumble upon something that will change everything. One discovery was meticulously planned. The other was a complete accident. But both revealed rays that are totally invisible to the human eye. And what they showed us? Well, it would not only turn science on its head, but it would give us a brand new way to see the hidden worlds all around us, and even inside of us.
So, it all really boils down to this question. How on earth does a faint, unexpected glow in a totally dark room lead to a revolution in physics and medicine? Well, that's the story we're going to trace right now.
To really get what happened, we have to rewind a little bit, back to the late 1800s. It was a time when physicists were absolutely obsessed with this bizarre phenomenon known as cathode rays. So try to imagine an almost completely empty glass tube, like a vacuum. When you zap an electric current through it, this eerie light appears, and it seems to shoot out from the negative electrode, which is called the cathode. Now, this glow wasn't just weird to look at. It could actually make the glass tube itself light up, and it could even make certain chemicals placed nearby start to glow. And it's this glowing, this luminescence, that was the starting point for our first story.
And this is where Professor Wilhelm Roentgen enters the scene. On one very specific day, November 5th, 1895, he was deep in his lab messing around with these exact same rays. But his very methodical work was about to take a turn that he never ever saw coming.
The key to his whole discovery was proving that what he was seeing wasn't just the cathode rays themselves. So first, he sealed his tube in black cardboard to make sure no visible light could escape. Then, in his pitch-black lab, he flipped the switch. And almost right away, he saw this flash of light. But it wasn't from the tube. It was from a piece of paper coated in a special chemical sitting all the way across the room. Now, this paper was only supposed to glow when it was right next to the tube. He turns the power off, the glow disappears. He turns it back on, and there it is again. He even took the paper into the next room, closed the wooden door, and you know what? It still glowed. Something invisible was passing right through solid objects.
Years later, someone asked him what he thought in that exact moment, and Roentgen gave this pretty famous, kind of blunt answer. Now, of course, he was thinking like crazy, but what he really meant was that when he saw something he couldn't explain, his first instinct wasn't to just sit there and dream up theories. It was to test, to prove, to experiment over and over and over again.
And because he truly had no idea what these rays were, he gave them a name that just perfectly captured that mystery. He used the symbol from math that we all use for an unknown quantity, X. He called them X-rays. And, yep, the name stuck.
So news of Roentgen's discovery spread like wildfire through the scientific world, and it totally captured the imagination of a French scientist named Antoine Henri Becquerel. He was so inspired by X-rays that he started looking into a related idea, but his big breakthrough wouldn't come from a successful experiment. No, it would come from one that failed.
What's just so fascinating about Becquerel's story is the role of pure dumb luck. He had this theory. Maybe things that glow in the sun, fluorescent materials, also give off X-rays. So he puts some uranium salt on a photographic plate, wraps it all in black paper, leaves it in the sun, and boom, the plate was fogged. His theories seemed right. But then, a string of cloudy days hit Paris. He couldn't do any more experiments. Frustrated, he just tossed his uranium and the unexposed plates into a dark desk drawer. A few days later, just on a whim, he decides to develop one of those plates anyway, maybe expecting to see a faint little smudge. Instead, he was stunned. The film was fogged just as intensely as if it had been in bright sunlight. The uranium was giving off these powerful rays all by itself, with absolutely no help from the sun.
And this contrast just shows you the two completely different ways you can make a huge discovery. Roentgen was slow, methodical, systematically testing something he already knew about until he found an exception. Becquerel, on the other hand, was chasing a wrong idea and just stumbled into a much bigger truth by total accident. The one thing they had in common? They were both prepared to recognize something extraordinary when they saw it.
Now, these discoveries weren't just weird little oddities. They were the first cracks in the very foundation of physics. The mystery of what these rays actually were would lead to an idea that was, at the time, completely unthinkable. The atom was not the smallest thing in the universe. It could be split.
Okay, so scientists were scrambling to figure this all out. In 1897, a physicist named J.J. Thomson solved the first puzzle. He proved that cathode rays weren't really rays at all. They were streams of incredibly tiny subatomic particles, which he called electrons. And X-rays? They were a super powerful form of energy, kind of like light, but way more energetic, that got created when those electrons smashed into a target.
And Becquerel's uranium rays? Oh, they were even more complicated. They turned out to be this cocktail of different things flying out. They had gamma radiation, which is like an even more powerful X-ray. They had electrons, the exact same particles Thomson found. And they had heavier particles that we later figured out were helium nuclei. And what that meant was absolutely mind-blowing. The uranium atom itself was spontaneously falling apart and throwing off pieces of itself.
This discovery just completely flipped physics on its head. I mean, before 1896, everyone believed the atom was the smallest possible thing, this fundamental, unsplittable building block of all matter, solid, stable, permanent. After 1896, scientists suddenly had proof that not only was the atom made of even smaller pieces, but, even more shockingly, that some atoms could just spontaneously disintegrate. This opened the door to the entire field of nuclear physics.
But the impact wasn't just theoretical, stuck in some physics textbook. The legacy of these invisible rays was immediate. It was practical, and it gave humanity a power that really must have seemed like magic.
4. That's it, just 4 days. That's how long it took after the news of Roentgen's discovery reached America for doctors to use his X-rays to find a bullet in a patient's leg, saving them from risky exploratory surgery. The speed at which this was adopted was just breathtaking.
All of a sudden, doctors had what they called a magic eye. They could peer right inside the human body without making a single cut. They could spot tiny bone fractures, find a swallowed coin, diagnose joint problems, and even see the very first signs of diseases like tuberculosis. Dentists could find cavities long before they were visible. And later on, these same powerful rays could be focused to destroy cancer cells deep inside the body.
And the impact didn't stop with medicine. Not at all. Industry started using X-rays to find tiny hidden cracks in metal parts, which made everything from trains to buildings a whole lot safer. Chemists used them to map out the complex atomic structures of molecules, opening up a whole new window into the building blocks of life itself. And that, really, is the ultimate legacy. From a mysterious little glow in a dark lab came a tool that lets us see things once thought impossible to see. It's this powerful reminder that sometimes the biggest discoveries begin when someone notices something strange in the dark, and instead of just shrugging it off, they decide to experiment.